So next lesson here, lesson 213, AC theory, more on the AC theory stuff, inductive and capacitive reactance, and then miscellaneous buildings. Listen, this is a pretty tough lesson. It's very technical, goes very deep into some theory, and I'm going to go over really the bare minimum. I think you guys, or the maximum you guys need to get out of this. Essentially, when it comes to actually calculating reactants, there are two different types you're going to read about in the book: inductive and capacitive. There's only 5 or 6 questions in your worksheets involving actually calculating reactants. I think that goes to show you how much weight should be put on this, and frankly, not much. So we're actually going to go over 2 of the problems from your homework. So like I said, there's 5 or 6 that involve actually doing math. We're going to do 2 of them right here. Okay. So first one comes from worksheet 213.1. It's actually question number 2. I want to actually hit inductive reactants first because that's the order you're going to read about it in your curriculum. So still, by all means, read through the curriculum. But you're going to find these formulas in there, sort of cherry pick the information we need to calculate these values. So the question reads, in a 60 hertz circuit containing a 1.3 millihenry inductor, the inductive reactance is blank ohms. Remember to change millihenries to henries. Okay, so first of all, what is the formula we're going to need to find this? That formula is going to be XL equals 2 pi FL. What does all that stand for? Well, let's break it down. XL is going to be our inductive reactance. That's what we're trying to find here. That's measured in ohms. Okay, so similar to resistance, right? Pi, of course, is 3.142. F is going to stand for frequency measured in hertz. And then L is going to be inductance measured in henries, or in this case, millihenries. So we're going to have to convert it, as they say here, back to henry. So let's go ahead and plug in the info we know from the equation here. So we don't know XL. We don't know the inductive reactance. That's what we're looking for. But we do know times 2 times pi, 3.142, times our frequency, which is 60, times millihenries, we're going to convert to henries. It actually comes out to 0.0013. So to go from 1.3 millihenries to henries, we're going to actually go, and we actually start here. So figure 1, 2, 3 places to the left to go to from millihenries to henries. That hopefully is old hat by now. So at this point, we're just going to go ahead and multiply everything through. Pretty simple. We should come out with 0.49 ohms for our inductive reactance. So it's as simple as that. Do I want you to understand what all those values mean? That'd be great. Do you need to? Again, frankly, this is pretty high level stuff. In my time, I've never needed to know this in the field. I'm not going to say that's the case for everybody, but at the very least, know how to use it and apply these formulas, right? So this is our first formula. We're finding inductive reactance. Okay, so sort of the other side of that is going to be capacitive reactance. That uses a different formula. Instead of inductors, we have capacitors here. So this time we're going to look at 213.1, question 1. So we're actually going to do the question right before what we just did. So in a 60 hertz circuit containing a 12 microfarad capacitor, the capacitive reactance is blank ohms. Remember to change from microfarads to farads. Okay, so first of all, what's our formula? So we're looking for capacitive reactance. So capacitive reactance equals 1 divided by 2 pi FC. What does all that stand for? Again, XC is capacitive reactance, as you might have guessed, measured in ohms. Pi, once again, is going to be 3.142. F is for frequency, measured in hertz. And then C is capacitance, measured in a unit known as farads. Okay, so what can we fill in from here? So right away, these values were all given to us, right? We don't know XC, we don't know capacitive reactance. That's what we're looking for. But we can do 1 divided by 2 times pi. Now let's go ahead and fill in what we know from the question. Our frequency, or the F value, is 60. Capacitive, or capacitance in farads now is going to be 0.000012. So to do that conversion, remember we were out here at 12. We're going to go 1, 2, 3, 4, 5, 6 to the left to make that conversion, right? That might be a kind of a new one. I think you guys have seen that before. But so now at this point, we have to remember order of operations. So this formula is a little trickier, but all that means is we have to do what's on the bottom side of this line and sort of in the denominator first, right? So let's go ahead and multiply all this through, simplify. That gives us now capacitive reactance equals 1 divided by 0.00452448. Figure that out. Go ahead and divide that through. Our final answer should be capacitive reactance equals 221.04 ohms. And if you actually calculate that, you get something slightly different. That's some rounding differences. That's the book's actual answer. So again, this is very high level sort of engineering electrical theory. At the very least, I need you to be able to pull out those formulas on the tests that I create. You guys are not going to see math problems based on this. You do have a few in the homework, but what I want you to get is really basically the vocab terms. Okay, so read through the textbook, pull out the vocab terms, be able to sort of talk about it and understand what these words are indicating, but don't get hung up on the math. I work through this specifically because I want you guys to be able to get through your worksheets and get it done. But again, don't get hung up on the finer details of this. So again, tough chapter. I would suggest reading through that textbook chapter at least once or twice. Grab those vocab terms.